Hello! Today we will be looking at Roman to integer, which is LeetCode problem number 13. This states that Roman numerals are represented by the 7 different symbols, I, V, X, L, C, D, and M. And then they go on to list out the values. So we know their Roman numerals basically read left to right. And you have the standard Roman numerals like 12, which is just XII. But there are 6 exceptions listed below. As we know, you don't say I, or for 4 you do IV. And we know to take V minus I, or 5 minus 1, you get 4. So the 6 exceptions are as follows. I can be placed before V and X to make 4 and 9, X before L and C to make 40 and 90, and C before D and M to make 400 or 900. So given the Roman numeral, convert it to an integer. So let's look at the examples they give here. First example, pretty standard, 3. Input is IV, and you get 4. Example 3, input IX, and you get 9. Example 4, LVIII, so 50 plus 5, 6, 7, 8, so 58. Now example 5 is a humdinger, because you have M, which is 1,000, but then you have C, which is 100, and then you have another M, which is 1,000. So it's like, well, wait, I've got to take M, I've got to subtract C from M to get 900, and then the same with, you have to subtract X from C to get 90, and I from V to get 4. So we do have some exceptions to go through. Okay, let's go to the pseudocode. We're given the method. We have an input, which is a string. So we're going to define a bucket to hold each Roman numeral and its number value. And we're going to access that bucket. We're going to pass in the Roman numeral and get the value back. We need to define a variable to hold the sum of all the numbers. So we're going to loop through each character in the string. We're going to get the current character's value from the bucket. Now, if it's not the first time through the loop, we're going to get the previous character's value. So in the example of 4, the previous character would be I, and the current character would be V. But the first time through the loop, you don't have a previous character, so we're going to skip that. We'll have to throw in logic to skip the first iteration. So if the current value is greater than the previous value, we need to handle that special case situation. Else, just add the value to the bucket and end the loop and return the sum of all the numbers. And we end the method. So how do you keep track of all the numbers and their indices? Well, we've seen this before. We're just going to use a hash map that stores the key-value pair. So the key will be the Roman numeral, and the value will be the value of the Roman numeral. The 2 methods we're going to use are the get method, so we'll have to pass it. Like I said, we'll pass in the Roman numeral and get the value. Returns the value. And then the put method, initially when we set up the hash map, to include all the Roman numerals and their values. And how do you pull individual values out of a string as we parse the string? We're going to use the char-et method. And basically, when you pass in the value inside the char-et method, it will return that specific character. All right. One thing I want to introduce here are ternary operators. And it's just kind of a way to clean up your code a little bit. So basically, you have a variable x. So if the expression evaluates to true, you're going to do what comes right after the question mark. Else, you're going to do what comes after the colon. So an example, basically, if roses are red, then violets will equal blue. If roses are not equal to red, violets will equal black. And it's basically shorthand for this. It's basically an if-else statement. And we just condensed it into one line. Okay, how do we deal with these exceptions? So let's use 4, which is the first exception we would come across if we started at 1. So we know we take v minus I, or 5 minus 1. And then we need to check to see if the current value is greater than the previous value. So we know that v, which is 5, is greater than I, which is 1. However, the problem arises in that we've already added 1 from the previous loop. So the first time we loop through the string, we're going to get I and assign that the sum equal to 1. Then the next time through, we're going to get the v, and we're going to know, oh, v is greater than I, so we're going to subtract 1, and then we get 1 plus 4 equals 5, which is incorrect. So how are we going to fix this? So let's just reiterate, we're going to use 4 here. So the sum, after the first pass, the sum is equal to 1. Now the second pass, the current value is 5, the previous value is 1. So what do we do here? We basically need to subtract out the previous value from the sum. Then we need to take the current value minus the previous value. And that will give us the correct answer. Now this is a 2-step process, so we can actually make it a 1-step process by just taking the current value minus the previous value minus the previous value. And we can condense that even a little bit more and just say the current value minus the previous value times 2. Or if you want to make it even more readable, you could put parentheses around previous value times 2, which you don't need to, but order of operations will do multiplication before subtraction. But just for readability, you might want to do that. All right, so let's code it. So we pass in a string. The first thing we're going to do is define that hash map. And we're going to use a character and an integer. The Roman numeral is going to be a character, and its value will be an integer. I will call it map, and I'll define a new hash map, or instantiate it. So basically, we're just going to put all 7 of these Roman numerals into the hash map. Okay, pauses if you need to pause the video here if you need to write all this down. But I'm going to continue on so this video doesn't get too long. All right, so the next thing we're going to do is assign the sum equal to 0 initially. Now we're just going to basically chunk through the string value. So here's where we use this char at that I was talking about. So we're going to take the current value, we're going to create a new variable called current value. So we'll start here with the first parenthesis. So we'll have 0 for I. So s.char at 0 is how this reads. And if we use the example we've been using through the whole video, which is 4, you'll see that s.char at will return the I. And then the map.get, passing in the I, will return the value, which would be 1. So int current value, in this case, would be 1. Now here's this ternary operator I was talking about. So if I is greater than 0, then we're going to get the previous value here. But because we're just going through the first loop this time, we're just going to assign it to the current value. And why do I do that? Well, the next step is to check to see if the current value is greater than the previous value. And if you take the first value, which is 1, and it's equal to 1, the previous value is also equal to 1, it's just going to bypass this step and go straight to the else statement. And we're just going to add the current value to the sum and close that out. So now the second pass through, I will be equal to 1, so we'll get char at position 1, which will be the v, and map.getv will return 5. So current value will be 5. And now we're going to use the previous value because I is greater than 0. So we'll do a map.get of I minus 1. So I is 1, minus 1 is 0, char at 0 is the Roman numeral I, which is equal to 1. And so current value will be 5, previous value will be 1. So then we do the magic code we were talking about earlier, where we take the current value 5 minus the previous value times 2. So 5 minus 1 times 2 is 2, 5 minus 2 is 3. So then we'll add 3 to the sum, and we'll get 4. And that's pretty much it. And return the sum, and close out the method. Okay, so let's go into IntelliJ and debug this. So the first thing we're going to do is create that hash map, and I'm just going to go through this quickly here. As you can see, the hash map has all 7 pairs in there. Alright, so now we'll go through. So I guess I should note that I passed in 4. I suppose we've been using 4 the entire time. So, okay, so the first time through, current value map.getChar at I will return 1. And the previous value, because we're on the first, you can see here it's false because I is not greater than 0. So you look down here, current value and previous value are both 1. So it's going to skip this piece and just assign sum equal to current value. So the current value of sum is 1. Now the second time through, current value char at position 1 will give you 5. And then the previous value, you can see now it's true, so it's going to execute this piece. So it's going to get char at 1 minus 1, char at 0. So now we see the current value is 5, the previous value is 1. So we're going to go into this block and basically add current value minus previous value times 2. And after doing that, you'll see the sum is 4. And that is our answer. Okay, so let's submit this in LeetCode. If I run the code here, accepted. Now let's submit it. 82.68% faster than all the submissions. And memory usage is faster, or is 39.4 megabytes, or 63%. Sometimes I like to submit it twice just to see if I can get a better number. Ooh, I shouldn't have done that. Alright, the last thing I want to do is go through the time and space complexity. So time complexity measures how much time it takes to run the algorithm. In this case, we have O of n because we have to iterate through all the characters in the string. And linear complexity here, so you notice as n goes up, the execution time goes up, and it goes up in a linear fashion. Now the space complexity is the total amount of memory, and the only thing that can increase at this point is the string value, or the Roman numeral. And because it's negligible, we have constant complexity. Doesn't matter how big the string is. And you can see that by the straight line. Okay, that's pretty much it. Let me know if you have questions, and thanks again for watching.